Hello, in this discussion we're going to be using the sum and difference formulas to establish identities. We're also going to do a few more examples also regarding these identities as well, so we're going to do both those here. But toward the end we're going to be doing a lot of proving of identities based on these formulas. All right, so let's begin. They want you to notice that the cosine of pi over 2 minus theta equals the sine of theta. And sine of pi over 2 minus theta is the cosine of theta. Now we've done this already in another discussion. We actually have graphed these, and we showed that the cosine of pi over 2 minus theta and the sine of theta was the same graph. So therefore, we were thinking at the time that they are going to be the same function. Well, in this one, we're going to be proving things like this by using these formulas. But we're also going to be doing a few examples as well. But I got to give you a few more formulas to discuss, and it's the sum and difference formula for sines. We already did the ones for the cosines in another discussion. Let's do ones for sine. So sine of alpha plus beta is the sine of alpha cosine of beta plus the cosine of alpha sine of beta. And if you notice, the formulas are very similar. Sine of alpha minus beta is the sine of alpha cosine of beta minus the cosine of alpha sine of beta. This is a good idea just to pause the video, write this down on your paper, and so you kind of become familiar with them. All right, let's look at an example. Okay, we're going to use the sum formula to find the exact value, kind of like what we did with cosine. We're going to do this one with a sine this time. So 19 pi over 12. Now 19 pi over 12 is the same thing as 16 pi over 12 plus 3 pi over 12. Now 16 pi over 12 reduces to 4 pi over 3. And pi over 4 is 3 pi over 12 reduced. And if you remember, 4 pi over 3 is a special angle because the reference angle is pi over 3. And pi over 4, of course, is a special angle. So you're going to break this up using the formula for sine, sum. So it's going to be the sine of the first, sine of 4 pi over 3, times cosine of the second, cosine of pi over 4, plus cosine of the first, cosine of 4 pi over 3, and times the sine of the second, sine of pi over 4. And then you just have to evaluate these. We've done all these four here at one time or another. So the sine of 4 pi over 3 is negative square root of 3 over 2. It's negative because we're in the third quadrant. Cosine of pi over 4 by our chart is square root of 2 over 2 plus cosine of 4 pi over 3 is negative 1/2. Again, we're in the third quadrant. That's why it's negative. Reference angle is pi over 3. And the sine of pi over 4, of course, is square root of 2 over 2. Do the math, and you get negative square root of 6 minus the square root of 2 over 4. Just remember in a previous discussion, I said the square root of 6 and the square root of 2 comes in. The only problem is there's a lot of different combinations you could put them, so you can't just guess, but there's a lot of different combinations that it could be. Alrighty? So it's negative square root of 6 minus the square root of 2 over 4 for the sine of 19 pi over 12. So guess what? That makes 19 pi over 12 a special angle now, because we use special angles to calculate it, and we were able to get the answer without a calculator, which makes it special. All right? So let's look at another example. We're going to find the exact value of this one, cosine of 40 times the cosine of 80 minus the sine of 40 times the sine of 80. Now you're like, okay, I'll just get my calculator out. Well, it's not the way we want to do it, because if you do it that way, it's going to give you a decimal. Well, there's a good chance it'll give you a decimal anyway. So what we're going to do is evaluate this without a calculator using the formula. You're like, well, which formula? Well, which formula has cosine times cosine minus the sine times the sine? If you remember, that was one of the cosine formulas. So it's the cosine times cosine minus the sine sine, and that's the cosine of the two angles added up. So in this case, basically the bottom line is they're giving you the right side and you're giving the left side. So then that becomes the cosine of 120 degrees because you add the angles. So it's basically using the formula at the bottom of the slide. Adding to 2 degrees up, 40 plus 80 is 120. And 120, guess what, is a special angle. So cosine of 120 degrees is negative 1/2 because you are in the second quadrant. Cosine is negative in the second quadrant. So you're like, what would happen if I did this on my calculator? Well, the calculator would give you negative 0.5. if you just punched it in directly, cosine of 40, cosine of 80, you put in your calculator in degree mode, minus the sine of 40, sine of 80, hit enter, it'd be negative 0.5. And I suppose that wouldn't be a big deal because the fraction does end. But if the answer was negative square root of 3 over 2, the calculator would have said negative 0.866 and a lot of decimals that follow. And so therefore would not be a good way to do it. So, but we're using the sum formula for cosine to do it without pulling out the calculator. All right. So another example here. We're going to find the exact values. Okay, if it is known that sine of alpha is 3/5, and alpha is between pi over 2 to pi. That's a fancy way of saying alpha is in the second quadrant. And that the sine of beta is negative 1 over square root of 5, which is the same thing as negative square root of 5 over 5. And beta is in between 3 pi over 2 to 2 pi, which is a fancy way of saying beta is in the fourth quadrant. So we want to find the exact values. You're like, well, why do we need to know what the quadrants are in? Well, hang on tight here. Look and see what happens. So cosine of alpha. Now, if you're looking for cosine of alpha, do you know what the answer is going to be as far as positive or negative? Yeah, you can, because alpha is in the second quadrant. Because it's between pi over 2 and pi. And since it's in the second quadrant, we know the answer is going to be negative. But look at the formula. Cosine of alpha is equals to plus or minus the square root of 1 minus the sine squared of alpha. Now, I'll carry the plus or minus down with me, but I know it's negative because it's in the second quadrant. So sine of alpha was given to me as 3/5. So I square the 3/5 because it's the square root of 1 minus the sine squared of alpha. Sine of alpha is 3/5. And then you just do the math. I'll still carry down the plus or minus. That becomes 16 over 25 on the radical. But since cosine is negative in the second quadrant, we'll put the minus. And so it's a minus 4/5. Square root of 16 is 4. The square root of 25 is 5 minus 4/5. All right? Now, to tell you the truth, we've done problems like this already in previous discussions. The reason I do it here is because I'm going to need it for parts C and D. Now, cosine of beta is, we're going to do that one now. So that's equals to plus or minus 1 over sine squared of beta. So very similar. Plus or minus the square root of 1 minus the negative square root of 5 over 5 squared, because that's what sine of beta is. So it's plus or minus the square root of 20 over 25, which gives me 2 square root of 5 over 5. Square root of 25 is 5. And it's positive. Why? Because beta is in the fourth quadrant, between 3 pi over 2 to 2 pi. And since it's in the fourth quadrant, cosine is going to be positive in that quadrant. All righty? So again, we've done A and B. We've done those in previous discussions. But we needed to know those in order to do C and D. So cosine of alpha plus beta is cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. Now, cosine of alpha was found in part A. Cosine of beta was found in part B. Sine of alpha was given to me in the given information. It was 3/5. And sine of beta was the second information, negative square root of 5 over 5. So I just put all those ratios into this formula, do the algebra, simplify, and it's negative square root of 5 over 5. So notice I can find the cosine of alpha plus beta in exact form if I know the individual angles for the sine and the cosine. I had to know the sine of alpha and the sine of beta. I had to know the cosine of alpha and the cosine of beta to do it. But cosine of alpha plus beta can be given in exact form without a calculator based on that formula. But I had to know those other ones. Same thing with the sine of alpha plus beta. Sine of alpha plus beta is the sine of alpha, cosine of beta, plus the cosine of alpha and the sine of beta. All right? So do the math. And there it is. All right? So that's the sine of alpha plus beta. So it's very similar. You just have to write the formula down and then put the individual ones in, and I had all four of them. So now you know why I did part A and part B, even though we had done this under a previous discussion. All right? Okay, as promised, we're going to use these formulas to prove identities. We're going to prove that the cosine of pi over 2 plus theta is the same thing as negative sine of theta. So in other words, if you were to graph the cosine of pi over 2 plus theta and graph the negative sine of theta, what should happen is the graphs should match. They should overlay each other exactly because they should be equal. That's what an identity is. An identity is when the left side equals the right side as long as they are defined, and these will be defined everywhere because it's all real numbers. So, but we're going to do it without the graph. We're going to do it by in this case, the sum formula for cosine. So let's begin. So cosine of pi over 2 plus theta is the same thing as the cosine of the first times the cosine of the second minus the sine of the first sine of the second. So I can evaluate cosine of pi over 2, it's 0, and I can evaluate sine of pi over 2, and that's 1. If you do the math, 0 times cosine of theta will still be 0, and negative 1 times the sine of theta is negative sine of theta, and voila, there's the right side. So it's very simple. Use the sum formula for cosine, evaluate the ones that you know, simplify, and that should be the right-hand side. All right. And now the sum and difference formulas for tangents. So again, you need to pause this video right here, and you need to write these down. So the tangent of alpha plus beta is the tangent of alpha plus the tangent of beta over 1 minus the tangent of alpha, tangent of beta. And the tangent of alpha minus beta is the tangent of the first minus the tangent of the second over 1 plus the tangent of the first times the tangent of the second. So as you can tell, I mean, we have a lot of formulas that we have to memorize. And back in the day, when I was your age and I was taking these classes myself, we had to memorize them all. These formulas were not under discussion. They said know them, and you knew on the test, and you had to know them all. There was no formula sheet. There were none of that stuff. You just had to know all these ratios. Times have changed, so we no longer require that these formulas be memorized so much. We still require you to know the fundamental identities, like the sine squared plus cosine squared equals 1, with those type of identities. We still require that. We no longer require you to have these memorized. Well, at least most instructors do not. All right. Okay, we're going to prove this identity again based on the identity at the bottom of the slide, tangent of alpha minus beta. So we just use that identity at the bottom of the slide to evaluate the left-hand side. And after you do the math, it should equal to the right-hand side. So it's the tangent of 2 pi, tangent of the first, minus the tangent of the second, over 1 plus the tangent of the first, and the tangent of theta, which is the tangent of the second. Now you just have to know what the tangent of 2 pi is. Tangent of 2 pi is 0. So it'll be 0 minus the tangent of theta over 1 plus the 0 times the tangent of theta. And so 0 minus tangent is negative tangent. And then 0 times anything on the bottom is 0, but add the 1 and it's 1. So what it turns out to be, the negative tangent of theta divided by 1, which of course is negative tangent of theta, and that is the right-hand side. So these identities, as far as identities are concerned, are quite simple as long as you know these difference formulas. If you know the difference formulas and how to evaluate certain angles, like the tangent 2 pi, if you didn't know what the tangent 2 pi was, you'd be in trouble. So you kind of got to know that. But you also got to know this formula. So knowing this formula basically spells it out for me. So, but like I said, that will be provided to you on some kind of a formula sheet on the exam. And then you just still got to do a little bit of work because you still got to know what the tangent of 2 pi is. All right, let's look at another example. prove that the tangent of pi plus 4 plus theta is the same thing as the cotangent of pi plus 4 minus theta. Okay, a little trickier. So what we're going to do is we're going to evaluate the tangent of pi plus 4 plus theta. And that's going to be the sine. Now they chose to do the sine over cosine. So that's the sine of pi over 4 plus theta. And so then they broke that sine of pi over 4 plus theta up. And you're like, why didn't they just go ahead and just do the sum formula for tangent? I believe you could have. So, but they chose not to. And then that's going to be equal to, they evaluate all the pi over 4s. So the sine of pi over 4 is root 2 over 2. The cosine of pi over 4 is also root 2 over 2. So put all those in. Take the square root of 2 over 2 out. And it leaves you with cosine of theta plus the sine of theta. Okay? Over cosine of theta minus the sine of theta. No, you can't cancel any of those out. That's all you can do. All right? Now, let's look at the right-hand side. Cotangent of pi over 4 minus theta is going to be the cosine of pi over 4 minus theta minus the sine of pi over 4 minus theta. Now, using the difference formulas for those, and remembering the root 2 over 2, and then you can take the square root of 2 over 2 out, and then cancel those out, and then you get the left-hand side. So, now this way they have demonstrated this one. Now, this one wasn't mine. This one was the author's. The way they demonstrated this one was they evaluated the left-hand side and they evaluated the right-hand side, and they showed you that they actually equal the same thing. Not the best proof technique, but it works. I would have done this a little bit differently, but that's okay. So tangent of pi over 4 plus theta, they broke it to sine and cosine, and then they evaluated all the trig functions at pi over 4. And then those ended up canceling on both of these identities, both the left-hand side and to the right-hand side, leaving you the left-hand side equals the right-hand side. So they are equal. Like I said, I would have done this a little differently, this is a good showing. There are a lot of ways to prove an identity. This is one of them. Not one of my best ways I would want to do it, but this is a technique that would work. The way I have in mind would have just used a tangent one to begin with. But that's okay. It works this way as well. Okay? Now, that concludes this discussion. If you have any questions on it, you let me know, and we'll talk about it. And you have a good day.